Good morning, I am Renu Sharma, Assistant Professor, EC Department, Ajay Kumar Garg Engineering College. Now, today I am going to start with the next lecture, that is multiple access for the subject, that is data communication network, and its code is KEC 063. So, the contents of my lecture are data link layer, then multiple access protocol, then random access is there, Aloha and types of Aloha. In the previous lecture, I have discussed about the data link layer. Now, this data link layer is a part of OSI model, that is the second layer of the OSI model, that is responsible of forming the frames. So, in that description, we have discussed about HDLC, that is the high level data link protocol, that is a bit oriented protocol. So, this is how this HDLC has been used, that is the part of data link layer, and also we have discussed about the point to point protocol, that is also responsible for forming the frames. Then we will see the multiple access protocol, random access protocol, Aloha and different types of Aloha. So, this is the data link layer, which is basically divided into two functionality oriented sub layers, that first one is the data link control and next one is the multiple access resolution is there. So, this is how the two functions will be performed at this data link layer. First one is data link control, that is responsible for forming the frame, and frame will consist of the header, then data will be there and it is followed by the trail bits. Now, this header is nothing, it is the address, source address, destination address is consist of some specific code or the command that you want to perform at this using this particular frame or the data that you want to transmit. This is the data and this consists of the trail bits. This is also started with flag, ended with flag, and there is a frame check sequence is there to check that whether the error has occurred or not. So, this is a kind of data link layer. Now, next is the multiple access protocol. So, basically there are different types of protocols that are used, like multiple access protocols. The name is here. Why multiple access? Because in communication it is not possible that only every time it is not possible that two nodes or two computers or two devices are connected in a network. There are more than one devices who are connected in network. So, that is known as multiple access protocol, and there is a communication channel which has been set up between the transmitter and receiver. Now, this channel is responsible for accommodating all the information that has been sent by each of the user. Let us say 5 users are there at the transmitter side and they have to access a single common channel, and there are again 5 users are there. This is user 1, this is user 2, user 3, 4 and 5. This is again the receiver 1, receiver 2, receiver 3, receiver 4 and receiver 5, and this is the common channel which is being used over here. So, this channel is responsible for accommodating these data of the 5 users and to deliver that data to 5 different receivers. So, there are different types of protocols. First one is the random access protocol. This we will discuss over in today's lecture, that is Aloha. There are two types of Aloha are there, that is first one is the pure Aloha, second one is the slotted Aloha. You are going to see that what is Aloha and how the information will be sent in this Aloha. This is a very interesting topic, that how this data will be transmitted. Now, next is a type of random access protocol is CSMA. CSMA nothing, it is the carrier sense multiple access. CSMA CD is carrier sense multiple access collision detection. We will see what is collision and how it can be detected. Next is CSMA, that is a carrier sense multiple access collision avoidance is there, that is a CSMA CA part. Now, next is the control access protocol is there, which consists of the reservation, a polling is there and the token passing. So, this is the kind of control access protocol. Now, next is the channelization protocol, that is known as FDMA, TDMA, CDMA, that is the frequency division multiple access, time division multiple access and code division multiple access. So, we will see first random access protocol. In random access or contention methods, no station is superior to another station and none is assigned to control over another station, and also no station permits or does not permit another station to send the data. At each instance, a station that has data to send uses a procedure defined by the protocol to make a decision on whether or not to send. Now, what is random access? As in this case, this description is there. What does it mean? Random access means you have the number of users who are connected in a network, who have formed a network. There is no proper sequence that whether the first user will transmit the data, then second user will transmit the data, then third user will transmit the data. It is all random in nature. If you can see, let us say there are 3 users are there. This is user second, this is user third. They want to access a common channel. Then this is user 4, this is this is receiver 1, this is receiver 2 and this is receiver 3, and this is the proper channel which has been shown over here. Now, there is no control on this network is there that whether first user will transmit the data, then second user, then third user, means proper numbering or sequence is not decided. It is all random in nature. Whichever user has the data and whichever wants to transmit the data, they can transmit on their own. Without seeing that whether the particular channel is free or not, it is sitting ideal or not, it is ideal or not, it will going to transmit the data. Like I have received the data, I want to transmit the data, I will transmit the data without seeing that whether the receiver is ready or not, whether the channel is available to me or not, whether second user is transmitting at the same point of time. May be possible that the second user will going to transmit the data at the same point of time. So, this is the work of random access. So, in that case there is a advantage and there is a disadvantage. What is advantage? That I do not have to wait for a particular point of time that when the channel is free, then I am going to transmit the data. I will transmit the data whenever I want to transmit that particular data. So, there is no sitting time is there at the user side. What is the disadvantage? Let us say user 1 transmits the data whenever he or she wants to send the data, but user 2 is already accessing the channel, then in that case the collision will take place. Collision means loss of information will take place, overlapping of the packets will take place. So, this is the random access disadvantages there. So, this is the first kind of Aloha that we have seen, and there are 4 different users are connected in this network that are denoted by station. This is station 1, then station 2, station 3 and station 4. So, 4 stations are there. These are going to transmit the data in the form of frames. Now, since this frame is related to the first station, so that is why it is written as 1.1, nothing very specific about it. You can write frame 1, frame 2, then 3, 4, 5, 6 and so on, but to link it with the first station we have written 1.1, then we have written 1.2. This is second station first frame, this is second station second frame, this is third station first frame, third station second frame, then fourth station first frame, fourth station second frame. So, this is the numbering. Now, what is collision? Okay, if you can see in this diagram that first station has transmitted the data which is known as frame 1.1, okay. Then it has transmitted after a time interval, let us say t naught, it is not fixed. Whenever I have the data, I will transmit the data. There is no time fixed. Let us say after 1 hour, after 15 minutes, I will transmit the data. No, this is not the case in this random access. So, I have transmitted this 1.1 2 frame. Now, you can see clearly see that at the same point of time, but there is some time lag you can say, or prior to this transmission, station 2 has already transmitted the frame, station 3 has already transmitted the frame, and 4th has also transmitted the frame, because if you can overlap this time duration, then all these has already transmitted the data. But what the problem is there, that frame length is fixed. Okay. So, frame length is fixed, then it will going to collide, because before the end of this particular frame it has started, the first frame has started, before ending of this frame data has started, and again in this case also. So, this is known as the collision duration. This is shown by this duration, that all the frames have collided. Now, what does it mean by collision? Collision means that there is a loss of information that has taken place, and loss of information means when the overlapping is being done, then because it is transmitted over a common channel, then there is no sequence is there. So, collision will take place and loss of information will be there. Next is collision duration. This is again the collision duration. You can say that only 2 stations have transmitted the data at same point of time, and the collision will take place, and this is the third station. So, that is the pure Aloha. You have seen the collision have taken place, but you have not seen that how you have detected, but you cannot correct it. Now, next is procedure for the pure Aloha. So, this is the flow chart, that how this whole process will work. First is the start station has a frame to send. This is the first station and it has a frame that it wants to send. Then what is k? K is the number of attempts, Tp is the maximum propagation time, Tfr is the average transmission time for a frame, and Tb is the back off time. So, what is k? K is nothing, it is the number of attempts that has been done. Like it has started from 0th attempt and it has to be ended at some point, because you cannot say that for the full day or for 3-4 days you are transmitting the data in that particular time, or in that particular time slot. You have to transmit the data after a particular time interval. So, from the 0th it is had started, and there are, if you can see that k max is maximally it is 15, means you have 15 to 16 attempts are there for proper transmission of data. So, second one is send the frame, it will going to send the frame, and the particular station will send the frame and it will wait time out time. So, 2 Tp means 2 into propagation time, it will wait. What is 2 into Tp? Let us say this is transmitter, this is receiver, it has transmitted the data over here, this is denoted by Tp, and it has to reverse back. Okay. So, this is again Tp, because the whole duration or the length of this is denoted by Tp. So, this is 2 Tp, it has to wait for that particular point of time. Then in the reverse part you have to transmit the acknowledgement. Then it will check whether the acknowledgement has received or not. If the acknowledgement has received, then success is there, means the particular frame has transmitted and it has received at the receiver side, and if there is no acknowledgement has received, then it has to check for the next attempt that has to be made, that is k is equals to k plus 1. Then k is greater than k max, it is nothing, it is the number of attempts will be should not be greater than 15. Then if it is so, then you have to abort, means you have to remove the ID or delete the ID of transmission. Then if it is not set to a maximum limit, then choose a random number r between the length, that is 0 and 2 to the power k minus 1. Then wait for the Tb time. What is Tb? Tb is nothing, is the back of time, which is denoted by r into Tp, or you can say that is denoted by r into Tfr. This is the Tfr is nothing, it is the average transmission time for a frame, and it is multiplied by r is nothing, it is the reverse time. Okay. So, this is how the pure Aloha will work. Now, next is the vulnerable time in pure Aloha. What does it mean? If you can see that this is T minus TFR, that is the frame time that is required to transmit the data, and that is this is T plus TFR, and at this point of time the data will be transmitted. And if you are going to consider this time duration, this is denoted by TFR, this is again denoted by TFR. This is the total time duration which is required for the transmission purpose of the particular frame, that is denoted by TFR. Now, you can see that this is B and B's and collides with the A's beginning. Now, A, B and C, there are 3 stations are there which wants to transmit the data. The A beginning is denoted by this one, that is A beginning, and this is A ending, this is C beginning, C ending, and this is B beginning and B ending. If you can see that how the collision will take place. Now, B's end will be collide with the A beginning. Before the B has ended the transmission, A has started the transmission. So, this is how the collision will take place, and this is again the case here where A wants to end the data, then C has begun the transmission purpose. So, this is the case for pure Aloha. Now, next is slotted Aloha. There is an advantage of slotted Aloha and a disadvantage is also there. Collision will take place in this case also, but a proper time duration is allotted in this Aloha. You have seen that this is the second type of Aloha, the time sequence is divided into different slots, like this is the first slot, this is second slot, third slot, fourth, fifth and sixth. So, the time axis is divided into different types of in different slots. We have divided into 6 different slots, and the first frame that has been transmitted from the station 1, that is denoted by frame 1.1. Then this is the collision duration. Why collision duration is there? Because the second frame and the third frame has been collided. Again there is a collision duration is there, because the first frame of the first station and the fourth frame of the fourth station has been collided again. So, this is the case for slotted Aloha. Then this is frame again, this is frame again, and this is frame again. So, this is the case for the slotted Aloha. This is the vulnerable time in the slotted Aloha. As you can see that again this duration is known as TFR, which is the frame duration, and this duration is again it is denoted by TFR. This is the A beginning, this is the B beginning, and this is denoted by the C beginning. So, A collides with C. So, this is the vulnerable time in the slotted Aloha that we have seen over here. Now, next is the space or time model in the CSMA. What is space and time model? Just see this diagram clearly with more concentration. There are 3 stations are there, that is station A, station B and station C and D. So, 4 stations are there, means A and B are the you can say A is the source, D is the destination, B, C are the intermediate stations which are connected in a network. Then at the time instant T1, A started the data area where A signal exists, this is denoted by this yellow color. This is overlapping up to this point, this A signal will be transmitted. Now, this is the area where both the signals will exist, where this area A and this C signal both will be exist. Now, this is the B signal which has been exist, which is shown by this blue color. So, this is the B's data, and this is how the space or time model in CSMA, that is the carrier sense multiple access will work. Means carrier sense multiple access means the carrier or the data which is been transmitted by each of the station. Let us say it will be either it will be station A, it will be station B, or it will be station C. So, whichever station wants to transmit the data, then it will be transmitted, but there is a specific space and time model is there. Now, next is the vulnerable time in CSMA. It is also been shown over here. This is station A, this is B, this is C and D. So, 4 stations are there which has their time axis which is been written over here. Then this B senses the data over here and C senses here, D senses here. So, this is one reliable time which is equals to the propagation time. This is frame propagation. Frame propagation means the data will be transmitted from this station A to station D. So, this is the one reliable time in the CSMA which has been shown over here. Now, next is the 3 persistent methods which are being shown in this slide. Now, there are 3 different types of persistent methods are there. First one is the one persistent, second one is the non persistent and third one is the p persistent methods are there. In case of this I persistent or one persistent, if you can see that continuously it is sensing the carrier, continuously it is sensing the channel, then it will going to transmit the data, sense and transmit the data. It will not going to wait, it will continuously sensing that whether the channel is free or not, then it will again going to transmit the data. In case of this non persistent method, this is the busy one, this will going to sense the data from here, it will wait for a particular point of time, then it will again sense, then it will going to wait again and then sense and transmit that yes, this frame is been this channel is free, non persistent. In case of this p persistent, if you can see that if it is sensing continuously and it is busy, then probability outcome does not allow the transmission. So, time slots will be allocated to each of the user and then the data will be transmitted over here. So, this is the 3 persistent method is there, like the first persistent, non persistent and p persistent. Now, this is the flow diagram which is showing the different types of persistent methods are there, how the these methods will work. This is station that can transmit the data, channel if it is ideal, it will sense the data. If it is ideal, then the station will transmit it. If it is busy, then it will going to check it continuously. So, this loop is continuous in nature. If it is busy, then it will not wait, it will senses continuously until and unless it is free. It will continuously going to check the particular channel. In case of this non persistent, it will check the channel. If it is ideal, then it will going to transmit the data. If it is busy, then it will wait for a particular time slot, wait randomly for a particular time slot, then after that it will going to transmit the data on that channel. Whereas, if we are talking about this p persistent method, then this is a channel is there which will going to check that this is the ideal method, this is the busy part, and it will wait for a particular slot, wait a slot, and then probability of outcome is there. If it is greater than p, then it will going to wait. If it is less than equal to p, then it will going to transmit the data. So, this is the p persistent method. So, these are the different types of persistent methods are there, I persistent, non persistent and p persistent. So, in this lecture we have discussed about different types of data link layer, what are the different types of multiple access protocols that are possible, and more we have seen more with more consideration. We have seen random access protocol. In that protocol, we have seen Aloha. Then we have seen 2 different types of Aloha, that is known as pure Aloha. Then we have seen the slotted Aloha. Okay, so, these are the different types of Alohas. We have seen its flow diagram, we have seen how the data will be transmitted in this Aloha part, and then it will going, then we have seen these persistent methods. And if you remember that in case of this random access protocol, there is an advantage and disadvantage. Whenever we transmit the data, it will going to we do not wait for second station to transmit, we do not check that whether the channel is free or not, then it will automatically when going to change the data. It is a random access kind of thing is there. So, that is why there is an advantage that transmission or reception will be done at a very fast pace, but there is a disadvantage that the collision will take place, because no one will wait for the channel whether it is ideal or not. It will transmit the data at the channel whenever they have the data to transmit. So, these are the references that we have seen, and you can follow for this topic. So, thank you.